Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to finish this chapter by studying about qualitative and quantitative analysis of organic compounds. Okay, so let's get started, and WhatsApp link is there. I need not say, you can check in the description section and join there. Okay, now coming to this part, today we are in the last part and we are going to do quantitative as well as qualitative analysis. Okay, so weightage, you know, this chapter itself has no weightage, but like less weightage, but it is very fundamental chapter for the next chapters. And yes students, so we have now on the eve of Christmas, so we are giving you special discount on this Christmas in our test series, so you can use our coupon codes to get flat ₹100 off. Okay, so the coupon code you can use is AISH100. okay, so if you click on this coupon, this price will change to $499, and in this $499 you will be getting 12 mock test paper including 4 part test and 8 full length papers. You will also be getting the PCM, like these subjects will be on PCM and CS. There will be the question papers based on the latest pattern and syllabus. You will get one-shot revision videos, you will get detailed video explanations of the solutions, plus the one thing, you will have also live doubt clarification class. Okay, so that's all students. Now let us quickly come to the qualitative analysis part. Okay, so in qualitative analysis, what we exactly do is we do not quantify that how much amount will be present, but we just think that, okay, how can we find that whether carbon is there or not, whether hydrogen is there or not. You just need to identify the elements. Certain reactions are done so that if this color change, okay, sulfur is there. If this gas is coming out, okay, nitrogen is there, right? That is called qualitative analysis, but you do not know exactly how much nitrogen is present, exactly how much sulfur is present. Those things we cannot predict here. Okay, so in qualitative analysis, what we do, we only identify the elements. Okay, you can say identify or detect the elements only. Okay, clear? We do not know the exact amount of elements present. Now the first, coming to detection of carbon. How will you determine whether a compound has carbon or not? This is very simple students. So what you have to do, so you have to heat in the presence of copper oxide. So what are the key points here? I will be telling you, just need to understand those things and remember those many things only. Okay, so you have to heat in the presence of copper oxide. Okay, so now what will happen if you heat in presence of copper oxide, carbon dioxide, you can find gas. Okay, and you can confirm it with the lime water test. All of you will be knowing about this, and the hydrogen present here gets converted to water. Okay, and how can you test whether water is produced or not? You can just put some anhydrous copper sulfate and it will turn itself blue. Okay, so for in a hydrocarbon we have two elements like carbon and hydrogen. To test carbon, burn in presence of carbon copper oxide, you will get carbon dioxide, and this carbon dioxide will turn lime water milky. Now for water, if H is there, you will get water, and water will turn copper sulfate blue, right? That's all. Next, you can see the reactions here. Okay, so you can see copper, you will get carbon dioxide, with hydrogen you will get water. Okay, next, coming to the one which is, that is detection of other elements. So like other elements means nitrogen, sulfur, halogens and phosphorus. Okay, these 4 elements how we can detect. So these 4 elements are detected by something called as Lassine test. Okay, different people can pronounce it in different way. Okay, so Lassine test you can use to predict the presence of these 4 elements. Okay, now what exactly is done? The elements present in the compound are converted from the covalent form into the ionic form by fusing the compound with sodium metal. Okay, so now you see this compound is there. Okay, it is an organic compound which has sodium, carbon, nitrogen. Now when you heat it, okay, you can, if carbon and nitrogen is there in presence, the organic compound is having carbon and nitrogen, okay, apart from hydrogen. Now what will happen when you heat it? The CN part will form an ionic compound as NaCN. Okay, next, if sulfur is present in that organic compound, that sulfur will come out from the organic compound and you will find sulfur, sodium sulfide. If any halogen is there, you can find NaX. Okay, so next you can see cyanide, sulfide and halides of sodium so formed on sodium fusion are extracted from the fused mass by boiling it with distilled water. This extract is known as sodium fusum extract. Okay, so what you have done, see, you have taken, just imagine, you have taken an organic compound, you have carbon, hydrogen, okay, you have sulfur, or you have, for example, halogen. Now if you heat this with sodium, what you can get, suppose nitrogen is present, so you can get NaCN, okay, you will get a product like this. Then you can get sodium with sulfur, NaS, sodium with chlorine, NaCl. Okay, now these all things are present in the mixture, and this mixture is called as sodium fusion extract. Okay, so from this we need to take NaCN separately, NaS separately, NaCl separately and do the testings. Okay, so first we will obtain the ionic form of the covalent form. Okay, fine. So this is, you can see how the sodium extract looks. Okay, this is, I think you can see, this is your what we say mortar pestle, that china clay, that one bowl type you might have seen in your lab, right? And in this crystal forms you can see this is your sodium extract. Okay, in this you have NaCN, NaS, NaX, everything is present here. Fine. Now coming to nitrogen. Okay, so for nitrogen what must be there? From the, or if the organic compound has nitrogen, carbon, hydrogen and nitrogen, when you heat it with sodium, that sodium extract, you would have got NaCN from here, right? So now this testing is done. The sodium fusion extract is boiled with iron sulfate and then acidified with concentrated sulfuric acid. Okay, so first what is there? So in this NaCN, what it is done, it is heated with Fe2 plus and you get FeCN6 minus. Okay, now this one, the formation of Prussian, now after this what happens, see, when you add some amount of when you treat it with Fe2 plus, you get FeCN6, right? Now what happens, there are certain unreacted Fe2 plus also, which in the presence of this one H2SO4, concentrated sulfuric acid, gets converted to Fe3 plus. So now this complex and the remaining Fe2 plus which got converted to Fe3 plus, these two will combine to give you this compound which is your Prussian blue compound, Fe4 FeCN6 whole 3. Now if you can find this blue color, then you can know that it contains nitrogen. Okay, now let me tell you a scenario. See, you have been given okay, now see, first what you have been given with an organic compound. You don't know what all elements are present. Your teacher told you to find it out. So what you will do first? First you will do and react it with sodium, okay, and you will get the sodium fusion extract. Okay, you will get sodium fusion extract. Now in this sodium fusion extract you can have NaCN, you can have NaX, or you can have NaS. We don't know what is there, we don't know, but any three of this will be present. Any one from this three will be present. So I am guessing that, okay, let me check. So first I want to check for CN. So what I'll do, I will treat this one with Fe2 plus and concentrated H2SO4. Okay, now if I get a blue color here, then what I can conclude, that this organic compound has nitrogen. Okay, that is how you will find presence of nitrogen. Next we can do the testing for sulfur. So for sulfur what we have to do, the sodium fusion extract is acidified with acetic acid and lead acetate is added to it. A black precipitate of lead sulfide indicates the presence of sulfur. Okay, so now what happens, the same thing if I see, I'll do, we have been given with an organic compound, you reacted with Na, right, then you get like this, if I draw, we get a sodium fusion. Okay, now this sodium fusion can be either, it can have NaCN, or it can have NaS, or it can have NaX. Okay, now what will happen, I am guessing that it may have sulfur. So what I'll do to this fusion, in this all three are present. Okay, we don't know which one. So in this mixture I will add now lead 2 plus. Okay, in which medium? In acetic acid. Okay, so now we can find a black precipitate here. Okay, we can find a if we are getting some black precipitate, then I can confirm that okay, this compound has sulfur in it, right? So on treating the sodium fusion extract with sodium nitroprusside, appearance of a violet color further indicates the presence of sulfur. So it's not only that you can treat it with lead acetate, and acetate, and you'll get a black color. You can also treat it with sodium nitroprusside solution. Okay, so you can see, so if you are having this compound and if you are treating it with sodium nitroprusside, okay, you get a violet color complex, and you get a if you are getting this violet color also, you can conclude that this organic compound has sulfur in it. Okay, so two methods to detect sulfur, one method to detect nitrogen. Okay, fine. Next, coming to, okay, so what was the name of that complex? Let me see. One second. Yeah, this is Prussian blue. Do not get confused. Prussian blue color is formed in case of nitrogen. To detect sulfur, you can add sodium nitroprusside solution, which will give you a violet color complex indicating the presence of sulfur. I hope this is very, very clear to you. Okay, now let us go to the next one. Okay, so you can see this reaction here. One second, let me clear this all things. Yeah, in case nitrogen and sulfur both are present, okay, for example NaCN is also there, NaS is also there, okay, in an organic compound the sodium thiocyanate is formed. Okay, so now for example this organic compound is there which has nitrogen, which has sulfur, and which has carbon. So in that case what will happen, if you react with sodium, you won't get NaCN separately and NaS separately. What you will get? NaSCN, sodium thiocyanate, you will get directly. Okay, so now the sodium thiocyanate is formed. It gives blood red color and no Prussian blue, since there are no free cyanide ions. Okay, so now if you treat this one with Fe3 plus and you are getting this blood red color, you won't get the previous color, that is what we discussed, Prussian blue complex you won't get. Now see, I think you might get confused here. See, in an organic compound, okay, let me explain you here. Suppose you have an organic compound, okay, and suppose this organic compound has nitrogen. Then when you did Na, you added to this, what you will get? NaCN. Okay, you will get NaCN. Now this NaCN is treated with Fe2 plus, okay, and H2SO4. The Cn minus, which is free ion present here, will react with this one and we will get a Prussian blue color. Right, but if this compound has also sulfur in that, then what we will get? This one which is formed is not NaCN, right? It gives you NaSCN, sodium thiocyanate. And with this 3 plus, if reacts with this one, instead of Prussian blue, what we will get? We will get a blood red color compound. Okay, clear? So that is how you can detect whether sodium is whether nitrogen is present, or whether sulfur is present, or both nitrogen and sulfur is present. Okay, next coming to the test for halogens. Okay, so in halogens we have chlorine, bromine and iodine. So first what we got, we have any organic compound, you treated it with sodium, we got NaX. Okay, now see, if there is chlorine, then after that you have to treat it with AgNO3. Okay, now here 3 conditions arises. If this X is chlorine, you will get AgCl here, and this is soluble in ammonium hydroxide. Okay, now if this is Br, okay, you will get AgBr, which is also yellow in color. Okay, and this is insoluble. Okay, insoluble in ammonium hydroxide, right? So you can see here a white precipitate soluble in ammonium hydroxide, yellow precipitate in yellow precipitate soluble in ammonium hydroxide, and if you have iodine, okay, then this one will give you yellow precipitate insoluble in ammonium hydroxide. Okay, so that is how you can distinguish between them. So now we have done what? Nitrogen also we understood. For for sulfur we have 2 tests. One is your using what was that, I forgot, with using lead and acetic acid, and another one was using sodium nitroprusside solution, right? So these are the two methods to detect sulfur. Then we understood how to detect halogens. Next we will come towards phosphorus. Okay, now we will see how we can detect the presence of phosphorus. Okay, so for phosphorus what we do is, now see, the compound is heated with an oxidizing agent, that is sodium peroxide. Now what will happen with that, the phosphorus present in the compound is oxidized to phosphate group. Okay, the solution is boiled with nitric acid and then treated with ammonium molybdate. Okay, a yellow coloration or precipitate indicates the presence of phosphorus. Okay, so what happens, first phosphorus is converted to phosphate group due to the presence of an oxidizing agent, that is sodium peroxide. Now once the phosphate group is formed, you treat it with nitric acid and ammonium molybdate to get a yellow precipitate. Okay, so you can see here, you can directly see from the phosphate group. Okay, so sodium phosphate is formed. Okay, now once this sodium phosphate you treat it with nitric acid, we get sodium nitrate. Okay, and once you treat this sodium, which nitrate we got, right, and in the presence of ammonium molybdate, we get a complex formula or a complex salt, and that is called as ammonium phosphomolybdate, which is yellow in color. Clear? Okay, fine. These are all about the, what I'll say, qualitative detection. Okay, so for, let us revise quickly. For nitrogen, what we have to do, first we have to prepare a lysine test, sodium fusion extract. Okay, then for nitrogen you have to treat it with Fe2 plus and then Fe3 plus, and you will get Prussian blue color complex, right? Next is your second one was for sulfur. Sulfur has, we have two methods, one is lead and acetic acid will get yellow color precipitate, another if you use sodium nitroprusside will get violet color precipitate. Now for halogens we have first treated with silver nitrate, then chlorine, bromine, iodine, three different colors will get. For phosphate group you have to first convert it into, for phosphorus you have to first convert into phosphate group, and then you have to convert it into nitric acid, treat it with nitric acid and ammonium molybdate to get this color. Okay, which color? Yellow color. Now we will talk about the quantitative analysis, means how exactly the amount of nitrogen, amount of phosphorus, amount of halogen present we can calculate. So let us first start with the carbon and hydrogen. For detection also we started first with carbon and hydrogen, so that is what we will do. So here is an apparatus to check to detect the amount of carbon or hydrogen present in an organic compound. So what here it is done, see, one organic, the sample is taken here, okay, and then the sample is allowed to undergo combustion. Okay, so now when the sample undergoes combustion, carbon dioxide and water will be produced. So here anhydrous calcium chloride and KOH solution is present. Okay, and in this you can see that water is collected on the anhydrous calcium chloride. Okay, here the water will be collected, and here the whatever water is produced, sorry, one second. Yeah, so whatever carbon dioxide is produced is collected here, and whatever water is produced here, collected here. Now their masses will increase, right? So what is the change in the mass of these two will be calculated, and that much amount of water and that much amount of carbon dioxide was produced will be calculated. Now based on the amount of water and carbon dioxide present, we can predict the amount of carbon and hydrogen present in the organic compound. I'll show you the calculation, it will be more clear. Now see, suppose what is there, suppose M2 amount of carbon dioxide is produced. Okay, so that means, see, in 1 mole of carbon dioxide, so I can say like this, in 1 mole or in 44 gram of CO2, right, we have how much gram of carbon? 12 gram of carbon. In 1 gram it is how much? 12 by 44 gram, right? In M2 gram it will be how much? 12 by 44 into M2. Right, so you have 12 by 44 into M2. This is the mass of carbon that is present. Percentage, how will you find? Divided by this M. What is the small m? So I'll write here M2 is mass of CO2. M is mass of organic compound. Okay, so this is the total. 12 into M2 by 44 is the mass of carbon present in the compound, divided by M into 100. Okay, so that is your percentage of carbon. Similarly, M1 is what? M1 is mass of H2O produced. Okay, so now if you see in 18 grams of H2O, there is what? 2 grams of hydrogen. In 1 gram of H2O, you have 2 by 18 grams of hydrogen. Okay, next in M2, sorry, in M1 gram of water, you have 2 by 18 into M2 gram of 2 by 18 into M1 gram of hydrogen, right? Now if you want to, so 2 by 18 into M1 is what? 2 by 18 into M1, this is the mass of hydrogen present divided by the total mass of the organic compound into 100 will give you the percentage. Okay, so please remember these formulas. Now we will go towards detecting nitrogen. Okay, so for detecting nitrogen we have two methods. One is your Dumas method and another is your Zeldal method. Okay, these two are the methods from where most of the questions are asked, from Dumas method and Zeldal method. Okay, so let us see here first. In Dumas method what we do, see, first of all, okay, you have, this is the setup. Okay, so the organic compound, okay, the organic compound when it burns in the presence of copper oxide and organic compound, okay, if there is any nitrogen produced or if there is any nitrogen formed or nitrogen present in the organic compound, it will form NO2 gas. Okay, so you can see the organic compound yields N2 gas on heating it with copper oxide in presence of CO2 gas. So what I am saying, if any organic compound is there, okay, you are heating it in presence of copper oxide, okay, copper oxide and carbon dioxide gas, then what you will get? You will get as a byproduct N2 gas will be formed. Okay, now the mixture of gases is collected over the potassium hydroxide solution in which CO2 is adsorbed and the volume of nitrogen gas is determined. So what happens now? See, so not only this one, you have also carbon dioxide gas is also there. So these all gases are produced here, are collected here, okay, and then the CO2 gas is adsorbed by KOH and only nitrogen gas is present. The volume of only nitrogen gas is known to you, right? Now how much volume of nitrogen gas is produced, related to that we can calculate in this organic compound how much nitrogen was present. So what's the formula for that? Wait. Okay, so now you see, for example, I say that, for example, I'll say that V ml, I don't know what is the amount, okay, let me say that V ml of N2 was produced. V ml of N2 was produced, okay. So now if you see that, what is the number of moles of N2 produced here, number of moles, this is the given volume, number of moles is what? Given volume by molar volume. Right, this is the moles of N2 produced, right. Now if you want to convert it into mass, then what you will do? Mass of N2 produced, how can you find out? Mass will be equal to V by 22,400 into 28. This is the mass of N2 produced. Okay, now M is the again mass of the organic compound, so V by 28 divided by 22,400 by M into 100 will give you the percentage of nitrogen. Okay, clear? So remember, 28 into V divided by 22,400 into 100 divided into M. Okay, so now let us understand the second method to detect the presence of nitrogen, and that is Zeldal method. Okay, so many of you get confused with this Zeldal method, so I want to tell you in brief. Okay, so first what we do, we take the organic compound containing nitrogen. Okay, now this compound is heated in presence of concentrated sulfuric acid, so that whatever nitrogen is there, that is getting converted to ammonium sulfate. Okay, now we have this ammonium sulfate mixture here, and you treat that solution with sodium hydroxide. Okay, so once you treat that solution with sodium hydroxide, what will happen? The NH4, the ammonium ion, gets converted to ammonia back. Okay, so now we are getting here ammonia is present. Okay, now you are titrating this one with a known volume of standard acid. Okay, so now we know, for example, that is V amount of nitric acid or V amount of acid is present. Okay, so now what will happen? We know how much amount was present. Now the reaction is completed. Some amount of nitric acid, some amount of acid will be present in the beaker, right? You do titration of that remaining acid with NaOH again. Okay, so now you will be able to know the amount of acid that was unreacted. Okay, that was unreacted. Now you know the total volume because you have taken it and you did titration and you calculated the amount of volume of acid which was unreacted. Now if you subtract these two, you will get the amount of H2SO4 which reacted with this ammonia gas. I want to repeat this part again. You took ammonia, you took H2SO4, okay. Now you have taken H2SO4 in excess. Some amount of H2SO4 will react with ammonia to give you ammonium sulfate, right? Some amount of H2SO4 will remain back or will remain unreacted. To calculate that remaining unreacted H2SO4, you have to titrate it again with sodium hydroxide. So you will know how much amount of H2SO4 did not react. You had the total volume of H2SO4, you got the volume of H2SO4 that did not react. So if you subtract these two, we can calculate the amount of H2SO4 that actually reacted with the ammonia formed here, right? So now you can see here what is, so now you see the reaction between like this, you have H2SO4, okay, unreacted, okay. This H2SO4 unreacted and you titrate it with sodium hydroxide. So what I will get? Na2SO4 plus H2O. Okay, so I will get 2Na, 2Na, 2 sulfate, then I'll get 2 hydrogen, and we have, I think hydrogen is not balanced. Yeah, I can make it like this. Okay, so now you can see here that this amount of, suppose what I can say, you have taken this known volume of NaOH, okay, so it is V1 suppose. Then what is this unreacted H2SO4? This will be V1 by 2, you can see V1 by 2. So I can say that total H2SO4 taken, this one, when you started the reaction here, how much known volume of standard acid, this known volume was in excess, okay. Now we calculated how much H2SO4 unreacted, so that means total H2SO4 was VML, unreacted is this one. Then what I can say, H2SO4 reacted is how much? H2SO4 reacted will be V minus V1 by 2, right? V minus V1 by 2, this much H2SO4 actually reacted. Okay, now what we can do, we can see the reaction between the, so what was the reaction? NH3 plus H2SO4, okay, gave me NH4 whole 2 SO4. So if I want to balance this one, I will get like this. So I can say that how much H2SO4 reacted, okay, twice of that ammonia must have reacted by seeing the relation. So if this much amount of H2SO4 reacted, right, then I can say that the ammonia present, how much ammonia will be present? That will be twice of V minus V1 by 2, right, twice of V1 minus V minus V1 by 2, okay. So now what we can do, we can calculate the percentage of nitrogen. How? So now you see this one is given, you have now, this is the volume of ammonia produced, okay, clear. Now here we have done a formula, you can see, okay. One more second, we can tell one more thing which was known here, okay, yeah, the one more thing, this M, right, fine. Now if you see this M is what? Molarity. So I can say that number of moles is equal to molarity into volume, right. So you can just multiply here molarity to get number of moles, okay. Now number of moles, so I can say this is number of moles of ammonia, right. Now number of moles into molecular mass 14, that will give you what? That will give you the what I'll say, this will give you the total mass of the compound. divided by 1000. Why we are doing? Because this volume is in ml. Okay, so we have to convert it into liter, into 100 divided by the m. So you can remember this formula like this. So 14 into m into 2 v minus v1 by 2 into 1000 by m into 100 by m. Okay, so this is the formula. Finally you can just correct it. 100,000 cancel, you can 1.4, you can substitute like this. Okay, so please remember this formula. This is very, very important. Next, coming to halogen. Halogens, you know how it will be done. Carriers method is used. Okay, the same thing, AgCl, AgBr will form. So for chlorine, 35.5 by 143.5. Okay, into the mass of the chlorine that is formed divided by the weight of the organic compound. Similarly, 80 by 188, 127 by 235. So this is how it is formed. Now see, suppose AgX is formed. Okay, so for example, I will do for chlorine. So in AgCl, or I can say in 143.5 gram of AgCl, okay, we have 35.5 gram of chlorine. In 1 gram it will be 35.5 divided by 143.5, right? Then what I have to do? Into the mass of the compound given divided by the total mass into 100. Okay, so next is for sulfur. For sulfur it is in terms of barium sulfate. Okay, so let the mass of the organic compound taken be m gram. Okay, and the mass of barium sulfate is formed is m1 gram. Okay, now in 1 mole of barium sulfate there are 233 gram of barium sulfate, or that contains 32 gram of sulfur. So m1 gram of barium sulfate will contain 32 by 233 into m1 gram of sulfur. Percentage of sulfur will be 32 by 233 into m1 by m divided by 100, okay, into 100. And next we have for phosphorus. So in phosphorus we form this molybdate compound is formed whose mass is 18877 gram, and if you see in this particular the phosphorus mass is 31. So 31 divided by 1877 into m1 divided by m into 100. Okay, and if it is estimated using magnesium, you have to use this formula. Okay, now we will do some questions. Carbon and hydrogen are detected by heating the compound with which of the following? So copper oxide, right? So CuO. Identify the element that cannot be detected by Lassine test, that is fluorine, option number B. Next, what is the Lassine test extract called as? Sodium fusion extract, right? Next, X color precipitate which is Y in ammonium hydroxide indicates the presence of chlorine. So chlorine was white color precipitate and which was soluble. So option number D. Next, on complete combustion, 0.5 gram of an organic compound gave 0.15 gram of carbon dioxide. Determine the presence of carbon in the compound. So this you can do very easily. So if you know carbon 44 gram contains how much? 12 gram of carbon, right? 1 gram of carbon dioxide will contain 12 by 44 gram of carbon. Next we have 0.15 will give me 0.15 gram of carbon. Okay, now if I want to calculate the percentage of carbon, it will be what? 12 by 44 into 0.15 divided by 0.5, okay, into 100. Now if I solve this, you will get 8.18, that is option number A. Okay, next, 0.35 gram of an organic compound gave 100 ml of nitrogen collected at 250 Kelvin temperature and 700 mm of pressure. Calculate the percentage composition of the nitrogen in the compound. Use Dumas method. Okay, so now you can see 100 ml of nitrogen was collected, right? So how can the number of moles of nitrogen will be how much? Given volume by molar volume. Okay, this is not at STP, so we can do like this. Volume of nitrogen, one second, we can use the equation PV equal to nRT. PV is equal to nRT. Okay, so let me use volume will be equal to nRT by P, right? Okay, I want to calculate number of moles, so I'll put like this. Number of moles is equal to PV by RT, right? So what is the pressure given to me? Pressure is 700 mm, right? Volume is 100 ml. Okay. Okay. Then we have R value is 0.0821 liter ATM, mole inverse, Kelvin inverse. Okay. And then temperature given to me is 250 Kelvin. Okay. Now here I need to convert this to ATM. Okay, and this should be converted to 100 ml, right? Not, yeah. So now see, conversion we have to do. 760 mm of Sg is 1 ATM. Okay, that means how much will be 700? 700 will be 700 by 760 ATM, right? So I'll just substitute the values here. Okay, so that all the values are in the units and we can see how the units is getting cancelled. So now you see here, I'll put for pressure 700 by 760 ATM. Okay, then for volume I will put 0.1 liter. Okay, next R value I'll put 0.083 liter ATM. Okay, mole inverse, Kelvin inverse, and then I have 250 Kelvin. Okay, now you can see liter will get cancelled, ATM will get cancelled, Kelvin inverse Kelvin will get cancelled, and finally what I will left with 700 by 760, right, into 0.1 by 0.083, okay, and then into 250. Okay, clear this one? Yes. So this is what number of moles. Clear? Now after getting this one, what we will get is we can calculate the mass of nitrogen. What is mass of nitrogen? Number of moles into molar mass. So I can write 700 into 0.1, okay, divided by 760 into 0.083, okay, into 250, okay, into 14 grams. Okay, so now if you get this one, this is the mass of nitrogen produced. Now if I want to calculate percentage of nitrogen, percent of nitrogen will be 700 into 0.1 into 14 divided by 760 into 0.083 into 250, okay, then into 100, and mass is 0.35. Okay, now if you solve all this, you will be getting around 35.71%. Okay. Next, using Carrier's method, find out the percentage of bromine in the compound 0.45 gram of organic compound, which gave 0.2 gram of AgBr. Okay, so if you know, in 188 gram of AgBr, okay, how much bromine is there? 80 gram of bromine is there. In 1 gram it will be 80 by 188. Then in we have 0.2 gram. In 0.2 gram of AgBr it will be 80 by 188 into 0.2. Okay, so this is the amount of bromine produced, right? This is the amount of bromine produced. Now this is the amount of bromine produced. Yes. Now if I want to calculate the percentage of bromine, so amount of bromine present, how much it is? 80 by 188, right, into 0.2, okay, divided by the total mass of the compound, how much it is? 0.45 into 100. Okay, so if you solve this now, you will be getting, let me solve this for you and let us check. Okay, so I'll write like this: 80 by 188 into 2 by 10, okay, so that I can cancel, and this is 45 by 100 into 100. Okay, fine. So I can cancel this one, anything else? No. Next I can do 5 9s are 45 and 5 16s are 80, right? Then I can do 2 1s are 2 94s are, okay. Next we can do 8s are 2, 4s are 8, 247. Okay, so I got 8,000 divided by 9 into 47. Let me put 9 7s are 63, 6, 9 4s are 36, 36 plus 6, 42, 423. So if I just calculate, you can see options are very nearer, so I have to go at least up to 3 digits to get the correct answer, or I can at least go to 2 digits to calculate the eliminate 2 options. So 800 if I do divided by 423, if I do 8,000, right? So if I take 2, it will be more, so I have to take 1 only. 423, right? 10 minus 3 7, 9 minus 2 7, 7 minus 4 3 I'll get, then I'll get 1 0. Okay, now which number I can take? If I take 7 and 8, 8 4s are 32, I think will be too much. 8 3s are 24, 8 2s are 16, 17, 18, 4s are 32 plus 1 33. Yeah, I can go for 8 also. So 8 3s are 24, 8 2s are 16, 17, 18, 4 8s are 32 plus 1 33. Okay, so we can eliminate these 2 options here. Now if I see, it is 10 minus 4 6, 17 minus 8 here 9, 6 minus 3 is 3, right? I did a mistake here, 1 second. So what I got, 6 plus 4 10 plus 1 9, 9 plus 8 17, yes, 3 plus, yeah, I got 386. Then I'll add one more 0 and decimal here. For one more 0 if I am getting, can I take up to 9 now? Right, so 9 3s are 27, 9 2s are 18, 19, 20, 21, 9 4s are 36, 37, 30, something 0.8, 0.9 I'll get option number D. Okay, so this is how you have to do the calculation. In the estimation of sulfur, the organic compound is heated with dash in a carrier's tube, sodium peroxide, right? We can convert it into sulfate group, right? So if you have remembered, let us check once again. Detection of sulfur, right? So where we have done, one second, let us calculate one spot. Halogens, phosphorus, yes, here it is sulfur. Okay, it is heated in the presence of sulfur, okay, to convert it into other group. Okay, okay, next is, okay, next question. The amount of water can be detected by the increase in the mass of dash during the quantitative analysis due to the mass of calcium chloride, option number D. Okay, so carbon, water will be collected here, and carbon dioxide will be collected on potassium hydroxide. Next, in Zeldal method of estimation of nitrogen, the compound containing nitrogen is heated with the compound containing nitrogen. Okay, we have this nitrogen where there will be, it is heated with concentrated sulfuric acid, right? Option number D, so that this nitrogen gets converted to ammonium sulfate. Okay, so yes students, again I want to remind you regarding the PU2 success blueprint test series. You already know what all things are there, I have already discussed, but the thing that I want to focus on is the Christmas offer that is going on. You can use the coupon AISH100 to avail flat ₹100 off on the price of the test series. So if you use this coupon, you will get the price test series at ₹499, and which will include 12 mock tests, one-shot revision videos, doubt clarification classes, as well as solution videos with detailed explanation. Okay, so that's all students in this class, and see you soon in the next class. Do not forget to subscribe the channel.